In this question, the air is a mixture of number of gases. The major components are oxygen and nitrogen with approximate proportion of 20% is to 79% by volume at 298 Kelvin. The water is in equilibrium with air at the pressure of 10 atm. At 298 Kelvin, if the Henry's constant of oxygen is 3.3 into 10 to the power 7 and nitrogen is 6.51 into 10 to the power 7 mm, calculate the composition of these gases in water. So according to the question, it is given that at 298 Kelvin, Henry constant of oxygen is 3.30 into 10 to the power 7 mm, and Henry constant for the nitrogen is 6.51 into 10 to the power 7 mm. The total pressure of the solution is equal to 10 atm. So in term of millimeter, we write it 10 into 760 mm. It's equal to 7600 mm. And now in the question it is given that the volume of the oxygen is 20% of the total volume. Similarly, volume of the nitrogen is 79% of total volume. So if we have to find the pressure, how much pressure the oxygen will carry, so we have to solve it by pressure due to the oxygen is equal to 20% of total pressure. It's equal to 20 divided by 100 into 7600 mm. So it's equal to 1520 mm. So we got the pressure due to the oxygen. Similarly, if we have to find the pressure due to nitrogen is 79% of total pressure, it's equal to 79 by 100 into 7600. So pressure of the nitrogen is 6004 mm. So now we have the total pressure of the oxygen and nitrogen, we found it. Now in the second part, we need to find the mole fraction of oxygen and mole fraction of nitrogen. To find it, we can apply the Henry law. So according to the Henry's law, P is equal to Kh into mole fraction. So for oxygen, it is pressure we already got 1520 and Kh value for the oxygen is given here 3.3 into 10 to the power 7. So here 3.3 into 10 to the power 7 into mole fraction of O2. So the mole fraction of O2 is equal to 1520 divided by 3.3 into 10 to the power 7. So mole fraction of O2 is equal to 4.606 into 10 to the power minus 5. So we got the mole fraction of O2. Similarly, we have to find the mole fraction of N2. So mole fraction for N2, it's equal to 6004 is equal to 6.51 into 10 to the power 7 into mole fraction of N2. Mole fraction of N2 equals 6004 divided by 6.51 into 10 to the power 7. So mole fraction of N2 is equal to 9.2227 into 10 to the power minus 5. So now we have the mole fraction of nitrogen. And in the question we have to find the percentage composition of both the gases. We have to find the composition of both the gases. So we already know that mole fraction, this is the value of mole fraction. So what is the total mole fraction? Sum of the total mole fraction is equal to sum of the O2 mole fraction plus N2 mole fraction. So xt is equal to 4.606 into 10 to the power minus 5 plus 9.2227 into 10 to the power minus 5. So total mole fraction is equal to 13.833 into 10 to the power minus 5. So we got the total mole fraction. Now we have to find the what is the percentage of oxygen, percentage composition. So to find the percentage of O2, it's equal to the mole fraction of O2 divided by total mole fraction into 100. So by substituting the value, it is 4.606 into 10 to the power minus 5 divided by 13.833 into 10 to the power minus 5 into 100. So the percentage of O2 is equal to 33.29%. So similarly, we have to find the percentage of N2. So percentage of N2 is equal to 9.2227 into 10 to the power minus 5 divided by 13.833 into 10 to the power minus 5 into 100. So we get 66.70%. So this is the answer of this question.